Hey, what's up everyone? Welcome back to another stream. This is the Count Monte Fisto with another sick stream. I'm still getting over a cold. I think hopefully this is the last day or two of it, and I'm good by Saturday. But anyway, as a result, I just been kind of tired, so aside from the JRPG morning stream, I wanted something off of my list that is a little bit low energy, and this game is certainly that. TIS-100. This is a game I bought off Steam about 2 years ago, maybe? For 99 cents. For 99 cents, it looked like something that would be cool. And I think it is. Even though, just a heads up, this game is boring as fuck. This is going to be a very boring stream. So this is for a very niche group of individuals. We'll call them autists. So if you are watching this and you get fucking bored out of it, don't shame out about clicking away. But what is this? Tessellated intelligence system. Well, tessellate is actually a word. I just looked it up. Decorate or cover a surface with a pattern of repeated shapes, especially polygons that fit together closely without gaps or overlapping. What does that tell us? Not much. But this game is made by a guy. Find his name. What Zachtronics. There we are. This is made by a guy called Zachtronics who does a whole bunch of programming style computer puzzle games. Usually with a general theme of hacking, but it's more like programming, really. But not even I guess it's more of a puzzle game with a programming theme, but you do kind of learn concepts of programming during it. So this is a very strange game. The game itself tells you nothing, and it comes with a PDF that you're kind of expected to print out, kind of like Keep Talking and No One Explodes. Is that what the game's called? Called? Yeah, Keep Talking and Nobody Explodes. Really good game, by the way. Very fun with people, that one. So this game kind of has the same idea where you're expected to print out a physical copy of the PDF and really get into the role-playing element of this. And I think I actually have a printed out PDF copy of it somewhere. Wonder. Hey, look at that! I found it. Cool shit. And we're actually gonna look at the PDF, because that's kind of part of the game, a major part of the game. Because when you first boot up the game, you don't know what the fuck's going on. The concept is that our uncle passed away. We were going through, well, I guess the family was going through his shit. They found a weird-ass old computer. They think, hey, little Wilmore Larry isn't quite the autist. Let's send him this weird-ass terminal from the 70s that we found. And it comes with some notes, and you kind of piece it together and try to repair it, and you slowly learn its initial function. Let's go into this, right? We'll actually play this music for a little bit. We're just listening to some PlayStation 1 music here. There we go. Alright, so here's what it looks like. It even has a picture of the staple, so you can staple along the staple. TIS-100, Tessellated Intelligence Reference Manual, and here's the little note from your Aunt Doris. M. The M stands for Mutterschuld, I can only assume. We are all still in shock here from Uncle Randy's son passing. While we wait on word from the examiner about the cause, we are coping as best as we can. It's a conspiracy. I've been occupying myself sorting through his things, especially his computers. Of course, I took one look in the garage, and it all looks like a bunch of junk to me. I'll send you some pictures when I get a chance. For now, this is the machine that was set up on his workbench when he died. Maybe you'll be able to figure out what he was doing with it. I would have liked to know someone was going to finish his work. Love and endurance. The Tessellated Intelligence System is a massively parallel computer architecture comprised of non-uniformly interconnected heterogeneous nodes. The Tessellated Intelligence System is ideal for applications requiring complex data stream processing, such as automated financial trading, bulk data collection, and civilian behavioral analysis. Notes like this one appear in the manual to indicate scenarios requiring special attention and refer to other documents that contain information on the topic. So your uncle got this computer from somewhere. It looks like a test node, a test terminal, for either finance or bulk data collection, civilian behavior analysis. It's like the proto. What is that? Oh god, we're gonna get sued by Squaresoft, aren't we? Squaresoft shit. Oh god, fucking YouTube. Oh well, it's gonna happen anyway. System architecture and organization. The tessellated intelligence system consists of a large number of independent nodes connected on a local basis. Refer to the yada yada specific manual to find the precise node population counts present on a particular device. Node types can be broadly classified as processing or storage, several variants in each category. Generally, nodes are connected to up to 4 neighbors via ports. And let me just say right now, you're not really expected to know what this shit means. Part of the fun is figuring it out. You're not supposed to look up this shit on a guide. You're supposed to look at the computer in the actual game, and then look at this notes and be like, what the fuck? And then slowly kind of be like, oh, okay, I kind of get it. And slowly learning. Yeah, it's kind of the puzzle element. This is a game that you don't want to look up explanations online, you know? Ports enable lightweight message passing communication between nodes. Communication over ports is coordinated by either allowing a node to issue a read or write to a port, and blocking until the request is filled by the corresponding node. If 2 nodes issue the same communication command, read or write, on the connection between them, the nodes will deadlock and a hardware fault will occur. Refer to the separate document, Tessellated Intelligence, and some best practices, patterns of node communication, for details of how to use ports effectively and safely. If a node issues a communication command and it is never fulfilled by the corresponding node, the node will deadlock and the hardware fault will occur. Exceptions to this rule exist. Refer to the documentation of specific node types for details. Refer to the separate document, Tessellated Intelligence Systems, yada yada yada, details. The document does not describe timing or throughput for node communication operations or instructions, as these values vary by model and hardware revision. Refer to the model-specific manual for detailed description of performance characters of a particular device. So this thing is only 14 pages. We'll look at this. There's some like vague clues of shit later in the game. This node type identifier is restricted to specific models of the tessellated intelligence system and will not be described in this document. Documentation for node type T20 is distributed only with systems containing this node type. Authorized requests for copies of documentation describing this node are reported to the State Security Bureau as required by law. This is some sort of like weird government computer. We saw civilian behavioral analysis, mass data collecting. This is like some proto 1970s Edward Snowden reveal shit. Let's read the highlighted shit and I'll kind of read shit as it becomes pertinent on my own PDF. After executing the last instruction of the program, execution automatically continues to the first instruction. So you have a couple of yeah, I mean think of them as like variables and commands, right? Like move, read, write, and then you have different values you can use: sub, neg, jump. And once again, when you're first looking at this shit, none of it's supposed to make sense. You're kind of supposed to like look at the game, not know what the fuck's going on, read the PDF, not know what the fuck's going on, look back at the game, kind of be like, oh wait a minute, and then look back at the PDF and be like, huh, wait a minute, and you slowly figure out this shit. But let's read our uncle's note. To do: figure out who sold the TIS to swap meet dealer. Rebuild signal multiplier. Look for a book of micro optimization tips. Renew license plate tabs. Our uncle got this for swap and meet of other autists and nerds. F2, view anti-tamper certification status. Some of these are like kind of secrets that you wouldn't know how to do in game unless you read this. But we'll read that in a bit. But that is the PDF. So for now, let's close this and get to the game. Oh wait, first let's turn that off. so here it's booting up. Hopefully you guys can see it in a second. There we are. So you kind of get a boot up screen. Of course, OBS doesn't capture the fucking footage until like 3 Mississippi pass. So this is what you look at when you boot the game. You have, well, these are actually leaderboards, but you wouldn't know this if you, unless some friends recommended to you. I recommended to my homies when I was fucking around with it. We have all this gobbledygook. What is this? 5 by 5, so you have 25 different nodes to choose. Specification editor. Right now, that's where we are at the TIS-100 segment map. So segments. In order to get to these, we have to repair the first one. So not even the self-test diagnostic is working on. And when you first boot this the first time, it strongly recommends like, hey, this game is meant to be fucked with the manual, and it kind of gives you a link. So because I already opened this, I fucked with it. The only thing I've done really that you guys haven't seen aside from the initial boot was I erased my save data for the purpose of the stream. But I got like around here, like I think I cleared the first like 6 or 7. But the game gets ball crushingly hard. First, let's try to look at that F1 and F2. F1, F2. Hey, look at that, F2. Anti-tamper certification. Tampering with the memory contents of this device is a violation of the law and must be promptly reported to the State Security Bureau. This device is registered to the Department of Defense Quantum Information Science Lab. So this is a DoD computer from like the 70s. And then we have a memory checksum. Once again, this is something that would be extremely boring, but if you find this shit interesting, stick around, and I recommend putting this on your wish list for when it's on. But you can make different programs. Open the save directory if you want to delete your saves, which I did. But let's create this first segment. Alright, now we are in the programming for the self-test diagnostic. Some of these nodes don't work. Some of these have commands already in them. Some of these don't have shit. So really the first test of this game is to really like look around. What do we see? See name of it. Read a value from in X and write the value to out X. Read a value from in A, write the value to out A. Well, let's use our eyes. Where do we see this shit? Well, we see in X, out X. Need it to be in 51, out 51. Need this to equal. Same thing with in A and out A. Okay. If we look at the screen, we have another in X over here, in A over here, out X, out A. And then we have all these arrows going down from here, passing all around here, going out, down. And then we have some of these. Let's hit run. Let's run the program. And that's it. Okay. That was really, really fast. This did shit. This side did not. We have the out X fast. The out A did not. There's nothing over here. So considering it's in, out, and it equals shit correctly, the X side is done. Move up, down, move up, down, move up, down. Those are the commands. So let's watch this step by step. You can also do it fast. Normal speed was not fast enough for you. Alright, so we see this shit. Everything's highlighted. We hit step again. And now we have the input here for A and X appropriately. Everything else is questionable, and then we have the down arrows lit up. This is still in 68, so this is trying to get down, but there's nothing there. This moved up, down, and now the 51's here. Now it's down because it moved from up and down. And each time it moves the next one. 51's being passed down, 14's being passed down. As 61 goes out here, it gets written there. So when I first fucked with this, that took me a long time, and that's kind of the point. But let's see if there's any clues in it to really... Oh, there's a page called Example Programs. Let's read that real quick. Following example program reads a sequence of values from the left port, doubling each value and writing that to the right port. That's using the additional thing. We'll get to that shortly. But the move and then a direction is kind of like read and write. So move is read and write, and the first command is where it's reading from, and the next one is where it's writing to. Reads up and writes down in one command. As you can see, 49 is at the top, goes down to the next one, goes down to the next one, output. And then it pops up right. You can see the mode box here. There's the last box, which we don't know what the fuck that does. Same with the bak and the ak. Idle is clearly how much it's doing shit. So because shit takes a while before it gets down here, this has a higher idle percentage than here. And then the mode is saying what it's actually doing. So read and write. Well, I guess now it's done. We can see it here. Read, write, run. Run. Or I guess run. I guess run and then write. I have a strange way of using that term. That's our first command. Move. MOV. So let's read the instructions for move. Find the ship. This is kind of how you play. You just dick around with this shit. Or does it even say anything about move? Might not actually. It's actually crazy. Wait a minute, this might actually not say what move does. Huh. Actually, oh wait, no, it does. I was just fucking blinding it. I was about to say, like, damn, that's kind of harsh. Syntax, move, and then it's source, comma, destination. Where it's reading from, where it's writing to. Description, source is read, the first direction. Second one, the resulting value is written to destination. Examples, move 8, comma, ACC. The literal value 8 is written to the ACC register. Let's do that for example. Let's do some of the example shits. Do move 8 ACC. Let's observe. This just writes 8 to the ACC and ignores the input from A. Which doesn't really help us at all. But what if we move the source being up here, look up, and then write to the ACC? Let's actually run that. And now it just keeps writing it to the ACC, which once again doesn't really help us. Next example, move left to right. A value is read from the left port and then read to the right port. Then move up nil. A value is read from the up port and then discarded. So really from this you can actually kind of learn a lot, but I think the example program page explains a lot. But the whole idea is that from this self-test diagnostic, from a fresh version, the left side is done for you already. The input X, output X, that's already done. So really it's kind of like showing you. They kind of expect you to stick around here, eventually hit that run, and kind of see what's going on here. Like, huh, the X is doing shit, the A is not. The X has shit written in it, and the A does not. Let's read this thing. So we have some nodes that we can't pass through, so like walls, essentially. Let's look at the debug. Compute node diagnostic, micro dump. 1C15SA64. Can't find a pen right now, so I'm just going to take notes here. Looks like a short-term storage. I guess like something RAM. 51079. Got this one at the swap meet today. So this would be our uncle writing. Fellow wanted $450 for it, but I talked him down to 200. Good deal. No idea who makes this thing. Never heard of the TIS series. The architecture doesn't look like anything I've ever seen before. Ask the guys down at the where that is, but no joy. So there's a little bit of corruption here. Randy has a mystery on his hands. Cool. So we're kind of like revisiting what our uncle went through. So if we moved up and down and just kind of copied this shit, what would happen? Nothing. It just kind of gets stuck here. Kind of like a traffic jam, you know what I mean? 68 stuck there with nowhere to go. 59's got nowhere to go. Everything else is backed up in the A. So, we can't go down there, but we can snake down here. So let's do that. Read from up and right to the left. Now it's getting stuck there because now we need to write something here. So move from right, then move it down. Do the same thing here. Up, down, then move up and write it to the right. There's a way to like, probably a hotkey to move around here. I just don't know it. From the left, then write it down. All right, let's do this shit, baby. First, we'll go step by step. Let's keep an eye on the right-hand side. We're looking for that 68 to be written. Coming down from here. Pass to the left. Pass down. Pass down. Pass right. Pass down. Output 68. That's what. Let's run that bitch. Hey, look at that, and we have a little happy ding. I don't know, like, if you're very high on the spectrum, you'll love this. Seriously, you'll probably, like me, get stuck, or maybe you're a fucking 2000 IQ fucking genius. But still, for 99 cents, you know, even if you play for like 2 hours and get stuck and can't get any further, that passes the dollar to hour ratio. And really, 99 cents, holy shit, you can fuck around in the city. Give like, was that like 20 blowjobs for a nickel a piece? Buy this game. So anyway, this is kind of like the best way to do this. So let's now return to the segment list. And look at that. The self-test diagnostic is nominal. So these are like little programs essentially we're writing for the entire computer to run. And this computer can now do a self-test diagnostic when initially gets to the ROM. You want to use your imagination. But I mean, that's kind of the point of this game, is to, you know, role play, get into it. Now, a signal amplifier. Of course, you really want to make a signal amplifier. Granted, this game takes place in the modern age. So, I don't know, would the DoD be like, holy shit, our fucking terminal from the 1970s is just shooting back a signal. Let's send some glow-in-the-darks to Wilmore Larry's house and beat his fucking kneecaps in and turn him into the next Epstein. But let's dive in. Let's dive into this. So now we want to read a value in from A, double the value, and write the value out to A. So let's look around here. We have the input A up here, output A down here. And we have all sorts of different directions. And there's a reason for this. I'll get into that in a little bit. But let's read the debug. Continues to 7/18/79. Continues to baffle. Chatted with Bernie at IBM, and he says it sounds like something they'd come up with in the USSR. Then why is the manual in English? Because it's the DoD. It's glow in the darks, motherfucker. So, let's. How can we double? Let's look at the examples. The examples actually practically tell you how to win the early ones. In fact, this one right here. Example programs. That gives you 2 of them. Following sample program reads a sequence of values from the left port, doubling each value, read, and writing it to the right port. Because of the automatic looping behavior of the basic execution node, it continues the first instruction after executing the last instruction. So, move left ACC reads the value left and then puts into the ACC, and we can add ACC. It adds the value in ACC to itself, doubling it, and then you move ACC, comma, right. Writes the value from the ACC to the right port. Starts over again. Let's read what ACC is. If I can find it. There's also an add option. The value of the source is added to the value of ACC, and the result is stored to ACC. Okay. Huh. Once again, still have a cold. In fact, I have a tea here that I was going to drink. Forgive me. God damn, dude. I'll tell you what, colds just suck. They really do. I was bitching about it in my Phantasy Star 3 stream. It's not the worst cold I've ever had, but it's still fucking annoying. Alright, where is this bitch? I'm trying to find it. There's like 2 sections of it. Basic execution node and then instruction sets. I'm not really sure. Why breaking it up in 2 different sections. Oh, I see. One of the sections is for variables and the others are for commands. So its initial one is just saying variables. So the one of them is left, right, up, down. Let's read that real quick because it's pertinent. The type is port. The 4 communication registers, and the ports being these arrows, these are the ports. 4 communication registers up, down, left, and right correspond to the 4 ports that all basic execution nodes use to communicate with topologically adjacent nodes. Some ports will be disconnected on certain nodes within the hardware, and will block indefinitely if a read or write command is issued. Refer to the interconnection diagram for the node to determine which port. So you really shouldn't just read the entire PDF, but you should kind of like read some of the first pages, stick around with it, and then kind of thumb through. It's only 14 pages. Just kind of thumb through and find the new information. Then read it, and you're like, oh, I can kind of see it going on. ACC internal. ACC is the primary storage register, which is the number here. The primary storage register for a basic execution node. ACC is used as the implicit source or destination operand of many instructions, including arithmetic, is that how it's pronounced? Arithmetic, but it's spelled with an E, crazy. And conditional instructions. Okay, so knowing that, and I guess we'll read the architecture first. We'll, obviously do a lot of reading here on the stream, but what are you gonna do? Oh god, drinking tea with like ginger in it, but it actually does help. It kind of burns your throat a little bit. With a sore throat, I don't know. It's like I don't know, vaguely refreshing, I guess. Not even really a sore throat I got. It's more like a fucking high as shit throat. But anyway, let's do this shit. 2, 2, 3, 5. All right. So, here's the thing, right? We could do this here and then move it down and just slowly bring them one at a time, or we could challenge ourselves and make it more what's the word I'm looking for? Efficient. There we are. So let's move up. Oh, oh wow! Look at that. I don't remember it doing that. Opera, and maybe that was from an update. I kind of played this when it was new, and even when it was new, it was 99 cents. Like this guy knew that this was like not gonna sell well. This is like a passion project, so I can appreciate that. Up, right, up, left. All right, and then right. Oh god, down. That work? Yeah, right. That's passing that, and then we could say up, right, up. Start to the right, and then do the next command to the left. Because it's going to take a little bit to multiply. So if we have two sections multiplying at the same time, it might be a little more efficient. Moving left, down, up, right, left, down, up, right. Oh god, I'm so goddamn dyslexic. I swear to God, my left and right and east and west, I fuck up all the time. I know that sounds really, really retarded, but I swear to God, I'll like misread phone numbers and I'll like say words out of order and shit. I honestly think there's some dyslexia there, and it's getting worse as I'm aging. I'm not even joking. So move up, left, right, down, up, right, left, down, up, right. But if it's going right first, we're gonna want to right, down, left, down, right? Yeah, because the right side's gonna be done first, then the left, and then the right, then the left. Let's like do this first, and then we're gonna choose 1, 2. I think it's gonna be the second to the last, where we'll have these be the multipliers. But that's why they'll give you extra space sometimes more than you need. Is because like actual programming, there's more than one ways to do things, and there are more like efficient ways. Hey, have you guys ever watched Terry Davis? Because there's one stream where he's like, the biggest question in programming. Just look that up. Look up Terry A. Davis, most important question in programming. Is this licious or is this divine? It's about the psychology, the philosophy of programming. Anyway, move left, down, up, left. All right, let's just check this. Let's make sure we're good so far. So first one is being passed to the right, pass to the left. That's a nice sound. Okay, cool. So it works, at least in terms of the movement. So Now we're going to move up. We'll do that thing we saw, ACC. Move up to ACC. And then, what was the other thing? I gotta like re-look this shit up. Oh, and there's like fucking keyboard shortcuts. Fuck. Undo last change, redo last change, cut selected text to clip, copy to text clipboard. Control and arrow. That's how you move around. F1 gives us a. Oh my god, that's beautiful. Save, swap, add, and then source to ACC. Adding ACC. We can do breakpoints. That way, if we're automatically doing it, if you put an exclamation point before something, shit gets paused automatically. I feel like it would actually drive you crazy, but allow you to easily debug code that would be stepped through time. Cool, but control and then arrow key. Random access memory node, T31. The random access memory node is not yet available in standard tessellated intelligent system devices. Emulators and prototype hardware are available to interested users. The specification and behavior not yet finalized, therefore is omitted from this document. 31. Stack memory. Shit that I might actually want to read. Part of me wants to do 2 streams of this. I feel like any more of that would be masturbatory. Anyway, we're just adding ACC to it. Let's look up that add function real quick. And obviously we know what it does, but if there's any more explained shit. Syntax, add, and then the source. The value of source is added to the value of ACC. The result is stored ACC. Add 16. Literal value of 16 is added to the value of the ACC register. Add left. A value is read from port left and then added to the. So if we wait a minute. So if we say move up, comma ACC, that reads up and then adds it to the ACC. If we just say add up, it just says a value is read from the left port and added to the. So if we said add up, it'd be the same thing as move up ACC. So let's actually do that. Actually, let's be a little creative here. Add up. And then we add ACC. Move ACC left. Is there a better way to do that? Maybe break up these commands to different locations. Add up. Then add the ACC to itself, doubling it. And then we move it to the left. There's probably there has to be. I'm sure when we look at the leaderboards, it's gonna be like motherfuckers who did it way faster than me. Add ACC. Add ACC. Read the ACC and then add the ACC to itself. ACC. Right. All right. Let's look at this one step at a time. First value 66. We want the output of 132. 6 goes in, sends to the right. 34 gets sent to the left. Yeah, 66 is over here now. 34 is over there now. Adding up. Now it's in the ACC. Now it's doubled. Then moves it to the left. Then this one is moving it down. Now we're going to have the output. And 68 is going in. That's being written to the output. Aha. Then we run it. I fucked up. Oh, do we have to clear the ACC? Wait a minute. Oh, damn. Oh, it just keeps adding it. Okay, so we're adding what's up to the ACC. And then we add the ACC to itself, and then we move it right, and then we add the incoming value to the ACC again. So we just keep adding to the ACC instead of writing to the ACC. You know what I mean? So we do want move up ACC. Move up ACC. All right, let's step this through. 132, 68, 176. All right, looks. Beautiful. Where are we at, baby? It's kind of hard to tell where the spread is. Cycle count statistics, node count statistics. So there's how many nodes. So yeah, I mean, I guess there's different ways to do it. You could say, aha, I used it using the least amount of nodes, but I guess the nodes are kind of like the CPU cycles, right? You kind of want to use what you got. You know what I mean? As long as you got speed and you're not smoking the fucking thing. So yeah. So really, I mean, I mean, I guess if you really want to, you can try to see if you can set it in the least amount of nodes and the least amount of instructions. But really, I feel like cycles is really what you want. It's a more efficient program. Like, yeah, you have nodes to use. And if your instructions are too wordy, but you're not using nodes, then the cycle's gonna be up. If you have a lot of instructions, but you're using a lot of nodes, then the cycles are gonna be down. So, I mean, really, that's probably what you want. I mean, yeah, there's not really like an advantage to doing it other than the satisfaction of like, aha, I wrote something more efficient. So let's return to the segment list. So now our signal is amplified. It's kind of spooky, honestly. So now we unlock 3 of them. And we have to repair 2 of those 3 to unlock the next 5. So you can get, like, these first 2, once again, this one in the node, the right side is done for you. So kind of, it explains in the program itself how to do it. You just have to kind of be observant. Segment 2, the signal amplifier, just tells you how to do it in the example pages. So it's like, first one is, are you looking at the fucking screen and thinking? And part 2 is, do you have the PDF? Are you actually reading? So now it gets a lot harder. A lot harder. Once again, I think I got the next 5. I never unlocked anymore. It's a hard fucking game. It really is. So let's look at the differential converter. Read values from A, end in B. Okay, and we have to write the shit from A minus B, A minus B out of P. And then we have to write in B minus A out to N. So N's going to be all the input of B minus A, and P is going to be all the input of A minus B. So, like I said, it gets fucking tricky real quick. Interesting. It looks like there's some kind of static memory in this thing, encoded something or other. Let's read all that we got. signal comparer. Comparator. Found a block of static memory, but it's in a proprietary format I never saw before. Can't make heads or tails of it. Oh, brother. There's just too many different kinds of machines coming out now. I like tinkering with them as much as the next guy, but when every Tom and Dick and Mary implements their own memory address scheme, it's all fucked. I, I say the bottom's going to drop out of the microcomputer market soon, mark my words. I might have an idea where this TIS-100 machine came from. Described the architecture to Fred at Motorola, and he says it sounds like it was designed for signal processing. I got my brain going. Government project maybe, something the CIA cooked up to comb through Soviet radio signals. Hush hush, top secret. Maybe. Could I be in possession of a classified device? Something for spooks? Glow in the darks, if you will? I might have to sit on this one for a little. Alright, look at this one. Read values from A and B. Read a value from input S. Then I write in A. Oh god. So if the input S is -1, then I write the input A. If S equals 1, then I write the input of B. We're comparing. And then if S is 0, I'm adding input A and B together. But 0. You see what I mean? Like, it gets fucking hard quick, dude. No, like, some motherfuckers probably look at me do the first two, and they're like, oh my god. Then I get to this, I'm like, fuck. Read A value from input, and I write 1 out to G. If the input is... I'm telling output G 1. If the input is greater than 0. I'm telling 1 to output L if the input is less than 0, E if it equals 0. And for every cycle where these shits don't get told 1, they have to be written 0. Do this differential converter, baby. Shit. Girl bitch. I swear to God, I did these first, like, I at least did the first 5. And then I unlocked the next 5, and I think I might have done 1 of the following ones, and then everything else is fucked. I think grand total I've done like 6 of these, but man, you hit a brick wall real fucking quick. So, what do we do? Let's read the next example program. Following example program reads a sequence of values from the up port, writes positive values to the right port and negative values to the left port. Okay. And we can label, baby. Alright. So, let's do an example of this. How? Shit. Fuck. How could you do this? Maybe like read up and send it right. And then read right. And then subtract it and send it on its merry way. and then have B do the opposite. How would I do that? Up, ACC. Move ACC right. Oh god, this is already convoluted as shit. Fuck, dude, fuck. Move up, put in the ACC, then move ACC right, and then the A column has a copy of ACC for itself. Like an idle option? And I'm kind of sticking to what I know. NOP. Nope is a pseudo instruction that has no effect on the node's internal state or communication port. Nope is automatically converted to the instruction add nil, which is do nothing. That's what I might need to do just so these are swap. The values of ACC and back are changed. ACC is written to back. BAK. BAK is like the backup. Sub source. The value of source is subtracted from the value of ACC, and the result is stored in ACC. Okay, wait a minute. Wait a minute. I feel like I kind of got this. I move up and then right into the ACC, and then I'm sending ACC to the right, and then I sub right. I move ACC down. Move up, down. Move up, down. This is not going to be efficient, but it might work. Then here, I'm going to have to add nil. Wait, ass nil, exactly. Wait, is that how you use nil? Is just say nope. Is nope. You just add nil is just saying add nothing to ACC. Same thing as nope. So this will put these out of sync. And let's copy that. And we're going to move up the ACC. Just like a RAM. Sub. Oh, yeah. Okay, fuck. Move ACC to the left. That work? Left. Why is this like fucking destroying my brain? They both send different numbers left and right at the same time? I guess we'll fucking figure it out, huh? Sub left. Move ACC down. Alright, let's look at this. And then why does it stop? Why does it stop? Oh wait, it's getting stuck on move ACC to the left. This is trying to move that to the left. Why does that get stuck? Fuck, I thought that was a good idea. So why is it getting stuck there? ACC right. Move ACC left. I guess they're just trying to do that, but they're not, unless it gets taken. And it just gets stuck there? Huh. Fucker, man. Alright. It's not working, obviously. Obviously it's not working. But why? What if I just like have it like that and then move up, down, up, down. Yeah, it just gets stuck there. It's like clogged up. I think they're both like talking, but neither's listening, you know what I mean? Alright, let's look at this back in ACC. Back. Internal, non-addressable. Back is temporary storage for values in ACC. It's only accessible through save and swap instructions. Cannot be read or written directly. Save it. Could I alternate them? Like have this one B move shit down while A is doing it, and then when it gets here, vice versa? How would that be done though? Up, ACC. No, we don't want that, right? Let's see, why does that not work? And move left. Why does that not work? Maybe I do need to use that backup function. Just not sure how I would use it. When any is used as a source of an instruction, the instruction will read the first value that becomes available on port. When any is used as the destination of an instruction, All of the instruction will be sent to the first node that reads from any port on node. Maybe? Not sure how this would work. I'm not sure how this would work. Let's do it anyway. And see if it does anything fancy. Oh, is it sending to all of them? Know what happened there. What is happening? Hold up, I don't even know what's happening here. Oh, wait. So it's reading up to the AC, the ACC. Accounting. I'm not sure what ACC means here. And that's there. Okay. And I'm moving the ACC to any. Sending 44 in every direction. Including this one, so it is going down. Oh, okay. This one needs to be specified. It's almost right, though. Do you see that? We got a 49 out. But it's like if they're both trying to do that at the same time. I don't know why that's so fucked up. Yeah, it just stalls. Trying to move it to the right. This one's moving to the left. Fuck. Alright, so I have to, like, differentiate. Up to ACC. Swap. Right into the backup. Oh no, god damn it. Oh, this is so hard. My brain. Okay, save is the value of ACC is written back. So maybe one of these I want temporarily to be save? And then we move ACC to the left. And we subtract what we're reading from the left. Being ACC down? That helped me. It might not. Fuck. It's where it gets caught, and I'm not sure why it's getting caught there. left the AC. We subtract the backup directly? We can't really read it directly, right? Wait a minute. Oh god, this is like a fucking mess now. The right to the ACC. A back? And yeah, fuck. Oh god. That's why you want to try to use more nodes. Fuck, I can't do them both at the same time, but I need a way to like save the numbers with very limited hands, essentially. Like you have the backup, but that backup you can either save to the backup or swap to put the backup value back to the ACC value. We can't really do anything with it. It's like very temporary storage. Fuck, we could come back to this one later. Fuck. Let's see where it's. Let's try the signal compare it to Tor. Probably even harder. We read a value from N. Write a value to G. Fuck. Fuck was it? Move. Read. Up. An ACC. See what we got. The value of ACC is arithmetically gated. Value of 0 remains the same. Wait a minute. Oh, wait, let's see here. JLZ. Transfer execution conditionally. Oh, look what I'm looking at. JEZ. Equals 0, not 0, greater than 0, less than 0. And then you have the label. Fuck. Okay, it has to be something with that. Negate ACC, subtract source from the ACC, save to back, swap with back. NOP is no instruction. How do I do label? It's just like a colon, yeah. Okay, okay. Here's what we do. Maybe. Start. And then we do a space. We don't have to do a space, but we're gonna do a space. We can do labels. This is how you can kind of label sub commands, some programs, whatever the fuck you want to call it. We move up ACC. And then if the value is want that shit in G. We want all that shit in G, dude. For now, we just want move up, down. What's the point of all this shit? I guess you can like have it move down there and have those work somehow. I don't know how you would. Move up, down. Move up, right. Okay, then we start. Left to the ACC. We put that shit in the ACC value, right? What do we have to do for G? Write 1 to out G if it's greater than 0. Okay. Fuck. brain is working. Fuck. So if it's, we want it out. Writing a 1. So if, the J jump is greater than 0, jump to 1. I'm about to define it, you dickhead. Give me a fucking break. Give me a fucking break. Fuck. Move 1 down. Then jump start. Right? Because we have this jump, right? Jump goes to any label. They're saying jump back to start. Oh god, my brain. Fuck, what's jump is equal to 0? Jump is equal to 0. Go to 0. And if jump is less than 0, is that a fucking thing? JLZ, yes, aha. We also go to 0. Then we jump back to start. So jump to start. Move 0 down and jump to start. Okay, cool. Holy shit. Oh wait, I need to I need to write it. Do I really need a third explanation though? Because it's always going to be equal to 1, equal to 0, greater than 0, or less than 0. At which point it's jumping there, so we actually don't need that. Fuck, but we still need to move. Move ACC right. ACC right. Okay. Okay, we're getting somewhere, maybe, kind of, possibly. Uh, what are we doing for E? Equal to 0. All right, all right, all right. Right? That's all I do. And we want to move the ACC to the right. And then here, we just don't need to move these to the right anymore. But what we do need for L is if it's less than 0, we're writing it down. So here, we're just changing this and this. Hopefully, hopefully this fucking works. All right, slowly. 2 is the input. 2 is the input. It's coming up here. 2 is being written down. 2 is going down again. 2 is going down again. All right, and then first trial. 2 is now going into the first fucking monster ass node that we wrote. It's gonna look at it. It's gonna be like, hey, that's greater than 1 because it's 2. It is. So it's gonna jump down to 1. It's gonna move 1 down. It's gonna say, hey, 1. 1 is the output for G. And that's gonna move that value to the right so that way they can do the same calculations fitting them. 1 goes in the output here, which is what we want. And this is gonna do the same shit. Oh my god, it's working. Hold up. Oh, I'm the smartest man alive. Oh man, what a fucking. It's a very satisfying game. It's very slow, very boring. You'll hit brick walls nonstop. When you figure this shit out, it's like, damn. There's definitely a way to do this infinitely more efficient. That's beyond me. No fucking way in hell. The fact I did this is a goddamn miracle. Oh, beautiful. Return to the segment list. Alright, so we got the signal comparator done. That differential converter is a fucking bitch, though. Oh my god. That's beyond my comprehension. I've done it before. No clue how. Let's go into the signal multiplexer. Oh fuck. Alright, read values from in A and in B. And we're also reading values from in S. And oh god. If S is -1, S is always -1, 1, or 0. Oh fuck, man. uh I've been watching Beavis and Butthead recently. Oh god. So how am I gonna do this one? I'm adding A and B together if S is 0. So I'm gonna have to like compare here. Oh man. And I guess I could just send shit straight down. Like have the S column do all the work. And S is like reading this and then comparing these two. How the fuck would I do that? That's a lot to juggle. Fuck. Alright, let's just start that. Alright, so let's move up right. We're just not gonna use nodes. Using as many nodes as possible is great if you're a galaxy brain motherfucker. But using less nodes that are more wordy, I think is easier if you're like a smooth brain. Up. I feel like that's all those should do. And we're gonna try to do everything else in these 3 here. Ah. Alright. So, how are we doing this? We're doing this with labels, because that actually seems to be a good way of doing it. So the start. Up to the ACC, right? Right. And fuck. Fuck, dude. Alright. Moving up to the ACC. That's a good first start. And then if we're gonna jump if it's greater than 0. There we are. Testing, testing. There we are. Oh, fun fact about this headset I've learned while recording for my 25 review video for PlayStation 1. I can be talking all goddamn day and it can hear input. If it doesn't hear, or like it can, hear output, but if it's hearing output but no input, no like music, it'll automatically shut down. And quite frankly, that's dumb, and I wish there's a way to turn it off. There probably is. I can't figure it out. So, if it's greater than 0, jump with pause. Yeah, no, I'm gonna define it. Jump is less than 0. We're gonna neg. Jump if equal to 0 will be. Fuck, we only have so much room to work with. Fuck. Pause. What are we doing if it's positive? Writing B. Write down. How do I discard? There's a way to like discard shit. I need to be able to uh move left. Nil? 0? Right, 0. Yeah, like take it and do nothing with it, right? Where's nil? Come on, where are you at? Oh wait, there's also a JNZ, J not 0, but so far we've had to whether it's 0 or not. Reading nil produces a value of 0. Writing to nil has no effect. Nil can be used as a destination operand to execute an instruction for its side effects only, discarding the result. I think that would work. So, was it JMP? Yeah. Jump to start. Egg. Oh man, I'm not even sure. If there's a way to do this. It's negative. I'm writing the input of A. I don't think this is gonna work. I don't think I have enough room. Fuck. You know what I could do? I could have S just like read the input and send it to the left and right, and then have A and B. No, but how would they see each other's shit? Central column has to do it. Because A and B have to be subtracted, which means there has to be some interaction. Let's fucking type this one out. Left, nil, right, nil, jump, start. And I run out of space. Fuck. Right. Fuck. I'm not even writing these down. Like, from this. Fuck. Is there a way to, like, simplify this to give me more room? Like, do I really have to specify jump start? Like, if it gets to the bottom, like everything else, wouldn't it just go up? Right? Like, could I do that? Alright, so let's move right to the ACC, and then we would add left to the ACC. Need too many operands. Oh, add left, and just adds it to the ACC. Right to the ACC. Add left to the ACC. And then we would move ACC down. Could I just do that? Move up, down. Oh no, fuck. God damn it. I need to move up, down. Move up, down. Sorry, hacking the FBI or something. Yes, I am now Terry Davis himself. Now it's like a puzzle programming game. Terry Davis would have loved it. Rest in peace. Alright, let's see if this actually jumps around or if it gets stuck in the pos, neg, and 0 without jumping back. Alright, so input comes in from S. It's -1. Which, it's going to jump down to negative. Going to move left down. Going to nil right. Oh, fuck. And then it just moves down to 0, which is what we don't fucking want it to do. God damn it. Oh, god damn it. Fuck. We're getting some of them right and some of them not right. Shit. Okay. God, there's just not enough room in these nodes. And I don't know how to, like, interact with multiple nodes. Unless I'm, like, passing these to each other. But then I would need the right side and left side to both get the S input while also trying to pass the B and A inputs to each other's side, and that's just way too much spaghetti. I gotta figure out how to efficiently do this in the S column. What I could do is have the first block see if it's positive. Oh god. Fuck, god damn it, this is hard. I could have the first block see if it's positive. And no. Damn it. Is there like a command that just jumps back to the start? Oh man. Last refers to the port last read or written using the any pseudo port. Well, I'm not sure how that would help me. What's up, Kundarsa? Hint, I can do label op arg. Do 0, move right. Oh, well, that's what I'm kind of doing here, right? Kind of doing it. Oh, like on the same line. Oh, fuck, I got you. Okay. Huh. Wait a minute. How'd that even fit? Do move RD? No. Maybe with no space? Fuck. Oh, you don't need a comma. Huh. Okay. Well, now it's fucking spaghetti. How would you know to do that, though? All the examples. Insane thing. I mean, I guess you could just keep trying different syntax to see if it fucking works. Nothing in the manual that would clue you in on doing it that way. Unless there's something towards the end that I just didn't see. Eh. Strange. Anyway, we're going to do it that way. We just have to clean this shit up now. Oh god. Oh god, now it's really like shitty now. All right, so let's try to clean this bitch up then. Move right down. We just had to clear this out. All we did was kind of copy it. And then jump to start. Okay, okay. Jump to start. Okay. Move left, nil that bitch, jump back to start. Right, nil that bitch, jump up to start. 0, right, add to that, add left, move the accounting down, and then jump to start. And then look at that. Yeah, that's my thing though. Is like, how would you know that you don't need the commas? Maybe there's something later that clues you in, or maybe if you're just like completely fucking stuck, you'll eventually dick around until you figure it out. Or maybe it's somewhere in here, and I just didn't see it. Anyway, all the same, we finished this one, so let's read some more. Wait, simple sandbox. Oh, I see it. So this is where you can kind of make your own programs. I think people have figured out how to do some weird shit in this. I'm not sure how you would, but people figured it out. But now we have 4 more segments here. That differential converter is a bitch, though. Sequence generator. Let's read some more of the story. Sequences are zero terminated. Read values from input A and B. Write the lesser value to out, and then write the greater value to out. And then write 0 after. Wow, that's fucked up. Kundarsara says not so much weird stuff in TIS-100, but the Shenzhen IO people have done some crazy stuff. Yeah, I think I own Shenzhen IO. I haven't fucked with it yet. This, go figure. I think this is the most simple of his games. True shit. And even this one, like, destroys my brain. POV, Fisto prevented God's chosen people from attacking his credit store. Yeah, I'm wearing my Guy Fawkes mask right now. You'll never use your chosen magic on me, motherfucker. So let's read this shit. 1994. Oh, that's a fucking jump, isn't it? Wait a minute. Oh. Yeah, all these were like 79 and 1980. So I guess Uncle, before he got killed by the glow-in-the-darks, kind of did the first 5 and then just stopped for years and then went back to it like in the 90s. So this must have been why he got offed, why he committed suicide by jumping off of the bottom bunk with a toilet paper noose, much like the chosen Epstein. The new girlfriend is encouraging me to get rid of the microcomputers I've accumulated over the years. Not a bad idea. Most of them are just taking up space and aren't doing me or her any good. I'm going to wait on this one, though. Never found out what its whole deal was, and if it turns out to be something I wasn't supposed to have, I think I could get in trouble. Cleared a little space on the workbench and hooked it up. Still works. Beautiful. Yes, it's a beauty, this one. Wonder how the Glowies murdered my uncle. My uncle. It's like a Shanghai noon. Right, let's check this shit out. Also 1994. No, she won't understand. Of course she doesn't. Why would you expect her to? Filthy thoughts! Just keep working. I feel like I'm learning about the people behind this and their design decisions. The thoughts that went into figuring out how things should work. People feel very close to me now. That's really the reward for clearing these things out, is finding more out about the glow-in-the-darks. And days, cycles and cycles, and just one after another. I'm sick and tired. People who don't respect me. Time to pack up. I wonder if this was like irradiating his brain. Let's check out this last one. I'll dig around for a little bit longer on this. We might do another stream, but like when I played before, I think I did the first 5 puzzles, and then like I think like one more I figured it out. But man, a huge brick wall after that, and really the point of this game is not to look up solutions and just copy the solutions. You really want to figure this shit out. It's 99 cents on sale, you know what I mean? Compute node diagnostic. 1994. My sister was over for the holidays, I think to check on me, make sure I haven't gone off the deep end. I know it caused some worry. Her kids saw me working here and suggested I could surf the web for TIS-100 specs. So even kids are on about internet, online, blah blah blah. These kids and their internet and their fucking hentai porn. It's a racket. I don't care about the information superhighway, and I never will. So yeah, yeah, I'm telling you, I like cleared this one when I played this when I first got it. I might have cleared one of them. I might have cleared the sequence generator or some shit. But I would have needed one more to get the next bit of information. Which, yeah, I can't. Let's try one of these and then call it to confirm. So we're comparing it, writing the lesser, then writing the greater, and then 0. I think this is the one I did actually. So I think I might try that one. If I'd done it in the past, I might be able to do it now. 0 terminated means write a sequence. Oh, like 0 resets, I guess. Write a sequence from the input and write the sum output S. Then the length to output L. Fuck that. Yeah, I definitely did not do that one. I can promise you that one. That's doing some weird ass wizardry with the few commands they give you here. This one, signal edge detector. Read a value from it. Compare the value to the previous value. Write 1 if it changed by 10 or more. If not true, write 0 instead. First output is always 0. Yeah, man. Definitely didn't do the generator, counter, detector, got handler. Read from input 1 through 4. Fuck me, dude. Write the input number when the value goes from 0 to 1. Wait, what is I mean, write the value goes from 0 to 1, like it increases. 2 interrupts will never change in the same input cycle. Yeah, man, these are like galaxy brained. Yeah, I can pretty much tell you, like, promise you, I did the first 5 and the sequence generator. These ones destroyed my brain. I kind of vaguely recall how I did this one, though. Ugh. The question is how? How did I do this? Let's see. How would you compare? I think I used like the back function for this one to temporarily save it. Then did like a negate, and if it was able to negate, I don't fucking know. Like I did some math, saved it to the back, and then like checked to see if it was a negative or not. And if it was, then I would read the ACC and write it down or some shit. I don't fucking know. God, this is a hard game, man. But yeah, if you are even vaguely interested in this shit, throw this on your wish list. It's 99 cents on sale. And just know that it's really hard, but even just doing the first couple puzzles are really satisfying. It's next level tism. Oh god. You can also do comments, which I guess if you're gonna do comments, you should probably like do comments in other ones, unless you're just doing like a one-line comment to be like comparing, multiplication, negation, you know? Yeah, the value of ACC is arithmetically. Yeah, I'm fairly certain that's what I did. I did something with saving and swapping and using negation here. Something like that. But I think I'm gonna call it here. Because we've stumbled around enough, but I think I did kind of my purpose of this game. the stream, I should say, which is just kind of show off what exactly TIS-100 is, which is a really interesting and cheap programming puzzle game that if you really want to rack your brain on some tough shit, I think eventually you will hit a brick wall with it though, and once you hit that brick wall, unless you're like next level autistic or you're computer science major or some shit, you're probably not going to get that far. But even someone with just very little knowledge of variables and commands and how shit works and solve the first couple and kind of feel. But yeah, chill game, interesting. I do really like it. It's just not something you can put in a metric fuck ton of time into. But for 99 cents, you'll get at least an hour, and I think that's worth it. Anyway, thanks again, everyone, for dropping in. Tomorrow morning is going to be more Phantasy Star 3. And then tomorrow evening, we're going to do some more Revenge of. Thanks again, guys. Peace out.